Just FYI, with me being gone, we didn't do a homework quiz for this past chapter. We'll do that this week, not today. So usually we do the homework quiz before the test, but with me being gone, it just didn't happen. So I'm going to give you a heads up right now that we're going to violate what we normally do, but we will do a homework quiz for this past chapter this week. Jack?
Did you have COVID?
I don't know. I never got tested. My wife did. I was sick before her, but only for a couple of days, so I don't know. All right. So the next chapter, chapter 7, is on exponential and logarithmic functions. So we're going to spend the first half of the chapter kind of talking about exponentials, and the second half talking about logarithmics, and then we'll kind of put them together at the end when we talk about solving, because we need the one function to solve the other function type, basically. And you'll see kind of why. But for right now, today, we're going to just talk about graphing exponential functions. So let's start by just defining what we mean by an exponential function. So we just say that an exponential function is in the form y equals a times b to the x, where the a is non-zero, the b is not equal to 1, and positive. So the reason we have all these extra little requirements on at the end, well, if a was 0, that would just simplify down to y equals 0, right? That's a constant function. That's something we've already defined. We don't want to include that. If b was equal to 1, that would simplify down to just y equals a, because 1 to any power is just 1 still. And that's a constant function also, y equals a, so we don't want to include that. And the reason that the b's have to be positive is, take for example, if you had a b that was negative, notice where the variable is. The variable's in the exponent, so you could have things like 1/2 or 1/4 or 1/8. And we know that all those things represent even roots, and the even root of a negative number is undefined. So you'd have a function that was just like undefined all over the place, which is not what we want to be describing here either. So that's why we have those 3 requirements there. Everybody okay with that? Okay. So next thing we're going to mention is that all exponential functions have this key feature. They all have a horizontal asymptote. And you guys remember those asymptotes? Those are those like dashed lines on our graph that the graph approaches but doesn't cross. Okay, so all exponential functions are going to have a horizontal asymptote. Horizontals are the ones that go left and right. Our general form for an exponential function is y equals a times b to the x minus h plus k. So our horizontal asymptote is going to be found just by y equals k. What happens if there's no k? What would the horizontal asymptote be? Just 0, right? Y equals 0. Not a big deal. It's the x-axis, right? Okay. So that's the general form. There's two types of exponential functions. There's exponential growth. That's where it's increasing from left to right. And there's decay. That's where it's decreasing from left to right. So we can identify a exponential growth or exponential decay function without really even having to look at the graph. We should be able to do that from the equation. So the criteria here is exponential growth is where the b is greater than 0 and the a is positive. And exponential decay is where the b is between 0 and 1 and the a is positive. So like an exponential growth where the b is greater than 1 and the a is greater than 0 is going to look like this. Now if we reflected that across the x-axis, that would be decreasing as we move from left to right. So that would be a decay thing. So the other type of decay is where that b is greater than 1, but the a this time is negative. And then your decay would look like this, where it's kind of going down as we go from left to right. But if we reflected that across the x-axis, it would now look like this, which is growth. So we have the other situation is if our b is between 0 and 1, but the a this time is negative. So basically the way I think about it is the first situation or the reflection of the opposite situation, right? So when we're graphing one of these exponential functions, the thing that we have to be concerned about is when we're making our xy table is that we're not just choosing our x's all willy-nilly, because the change between consecutive x's could be very, very small or very, very big, depending on how we pick them. So we want to make sure that we're picking them in a way that we get x's that'll make a decent picture. So the way that we're going to choose our x's for our table is we're just going to take the h value and then subtract 2, then 1, then add 0, then 1, then 2. If we do that, we should be guaranteed values that are not too inconvenient to graph. So let's do a couple of examples here. And then that'll be it for today. So the first thing we'll do is we'll identify the values for a, b, h, and k. So what is my value for A? 2. And my value for B is 3. My value for H is -1. Very good. And the value for K is +1. Remember, the value for H is always the opposite of what it appears in the function. Right? It's been that way like all semester or all year, really. So don't get tripped up on that. It's easy to lose sight of that. Next thing we'll ask, is this growth or decay? Let's go back and look at your criteria for growth and decay. This one is growth, because the B is bigger than 1 and the A is positive. Okay. So what's the horizontal asymptote in this case? Remember, the horizontal asymptote always exists for an exponential function. It's always of the form y equals k. So in this case, that is 1. So next thing up, we'll make our XY table and then draw a graph. So in our case, our value for H was -1. So we have -1 minus 2, -1 minus 1, -1 plus 0, -1 plus 1, and then -1 plus 2. Okay. So to find the y coordinates, all I'm going to do is plug this back into my function. Oops. So I'm plugging -3 in for x. That was my first x value. And then we'll plug -2 in. And then we'll plug -1 in. So FYI, what I'm doing on my calculator to just recall the last thing I typed in is I'm pressing second and the enter command. That'll give you the last thing you typed in, then you can just go back and edit what you need. In this case, we're just editing that one number. And that makes life a little bit easier, rather than having typed the whole thing in over and over and over again, right? You could also scroll and press enter, and it'll capture whatever's on your memory there. Right? Like if you want it, you could go and scroll back up and say, press enter on that, and it'll give you that thing, then you can edit it. Just from a little practical standpoint, makes it life a little bit easier than having to type all those numbers in over and over and over again. Not that that's the end of the world. Okay, so let's draw our graph now. Okay, so let's see, 1, 2, 3, 1. I have to go up to 19, so I think I'll probably go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'll draw in my asymptote, which is at y equals 1. There's my asymptote. And then I have -3 and 1.2, -2 and 1.6, -1 and 3, 0 and 7, and then 1 and 19. So to draw my graph, I'm going to start following the asymptote, and then I'm going to go through my points. And my graph will always get 2 arrows on each end, or 1 arrow on each end, so 2 total arrows. So that's what my picture looks like. Everybody okay there? Notice at the beginning it's growing very slowly, but all of a sudden it kind of shoots, takes off and starts growing very, very quickly, right? That's characteristic of an exponential function, is that it's growing very slowly and then it starts growing very, very quickly, or vice versa. The last thing that we'd want to talk about, what letter am I on here? Somebody? U? What letter? No, we're on. Looks like it. Oh, E. Oh, I guess I started with A and then I did numbers. That doesn't make a lot of sense. So I guess that should be B, C, D, E. Yeah, you're right. Thank you. We should talk about the domain and range. So since this graph has arrows at both ends, what does that tell me about the domain? It's going to be all real numbers. That's always going to be the case. Everybody's okay with that idea? The range, though, is going to be different. It'll depend a little bit. It'll depend on 2 things. So the range is always going to be like everything above the asymptote or everything below the asymptote. It'll be the y's on one side or the other of your asymptote, though. Everybody's okay with that notion? So the way you can tell which side is which by the A. So if A is positive, then we're going to go from the asymptote up to positive infinity. So that'll be the top of the asymptote. Or if the A is negative, we're going to go from the negative infinity up to K. So that's like the bottom of the asymptote. Notice here with the ranges, all of those are parentheses. Now, in this particular example problem, since the A was positive, we're going to go from K to positive infinity. That's kind of about it, right? They're all basically the same. Let's do one more just to make sure we got it. Sound okay? Coolsville, Daddy-O. Is it okay if I don't write out all the questions and we just kind of go like A, B, C, D, E? I'll just write the letter. Okay. So first thing, our values for A, B, H, and K. What's our value for A? 3. What's our value for B? 1. What's our value for H? It is 5. And our value for K is -2. Okay. Next thing up is this growth or decay. Well, is the B between 0 and 1, or is it bigger than 1? Let's start there. It's between 0 and 1. And then is the A positive or negative? Positive. So if we go back and we look at our criteria, this is the decay situation. Right? So usually when I'm doing this, I look at the B's first. So the growth situation is greater than 1. The decay situation is between 0 and 1, assuming that the A is positive. If the A is negative, then it's the opposite, right? It's just that's the way that I like to think about it. What's the horizontal asymptote? Y equals -2. Everybody good there? Okay. Let's make our table. So what would our first x coordinate be? Right, 5 minus 2, which is 3. And then what? Four, then 5, 6, and 7. Would you agree with that? So usually, typically, really all you need to do is find the first one with your little formula, and after that you're just counting up by ones, right? Now I wrote out everything just to be clear. Oops. But really, you don't need to do that. Okay. 10. Four. And 1. And then what, like do a half or something? -1/2. And then -1.25. Let's draw it down. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll draw in our asymptote here to start with. And we'll plot some points. So 3, 10. 4, 4. 5, 1. 6, -0.5, and then 7, -1.25. So here I'll just go through my points and then follow the asymptote. Notice here on the decay graph, rather than starting by following the asymptote, we end by following the asymptote. Should be pretty obvious, though, based on where the points are, what you'd want to do with that, right? And then the domain here would be all real numbers. It's always all real numbers for exponential functions. That's really nice. And the range here would be, since the a is positive, it's going to be k to positive infinity. Feel okay? Hopefully this feels pretty good. It's really pretty straightforward. There's nothing really tricky going on. We're going to stop here.